Hello, welcome to Chapter 3, homework questions 88 through 93. Question 88. If possible, draw a triangle that has exactly the following number of lines of symmetry, then name the kind of triangle drawn. So for 0 lines of symmetry, we would need to do a scalene triangle. It doesn't have to be a right scalene triangle, but any scalene triangle. And there is no lines of symmetry on something like that, so make sure you identify the type of triangle also. Part B, we have 1 line of symmetry, so we could do an isosceles triangle, so these two side lengths are the same, and there would be your line of symmetry. So once again, an isosceles. C, 2 lines of symmetry. 2 lines of symmetry. Right now we have a scalene, which none of the sides are the same, an isosceles, 2 of the sides are the same. If all 3 of the sides are the same, that would be equilateral. And if you draw an equilateral triangle, then we should be able to draw in 3 lines of symmetry. So this would be an equilateral triangle. So the question back is to part 2. Is there a triangle that has 2 lines of symmetry? Well, if we've already done scalene, isosceles, and equilateral, is there any other possibility? And there is not, so there is no triangle that exists that has only 2 lines of symmetry. Question 89. Do 2 lines always intersect? Consider this as your answer as you answer the questions below. Write a system of linear equations that does not have a solution. Write each equation in slope-intercept form. Graph your system on graph paper and explain why it does not have a solution. So 2 lines will never intersect if their slopes are the same. So that steepness would represent the same thing, so there's no way they would ever intersect. So let's just create an example where our slopes are the same. Y is equal to 2/3 x minus 4. So down here up 2 over 3. So you can get a couple different points. You can go down to the left 3. That's still a positive. A negative divided by a negative is a positive. So we have this line, and that's y equals 2/3 x minus 4. And then we'll create another one with the same slope. I'll do plus 2, move it up a little bit here. But once again, 2 over 3. So if the slopes are the same, those lines will never intersect, which means if they don't intersect, then there is no solution to the system. Whoa. So this is y equals 2/3 x plus 2. So we've written a system of equations that does not have a solution. We've graphed it, and we've explained why it does not have a solution, and that's because your slopes are the same. And since they don't intersect, there is no point of intersection to have that. So the lines are also parallel. When they don't intersect, that means they're parallel. So for part B, how can you tell algebraically that a system of linear equations has no solution? Solve your system of equations from part A and demonstrate how you know that the system has no solution. So we're going to solve this algebraically, and probably the easiest way on this one would be to use the equal value method. And we can just set both of the equations equal to each other since they're both equal to y. And when we subtract the x term, it creates these zeros on both sides. So all you're left with is -4 is equal to 2, and -4 is not equal to 2. That's a false statement, and since it's false, that means there's no solution to the equation, which means there's no solution to the system. There's no intersection point for that. Now, just to kind of further this just a second, in terms of what happens if instead of getting -4 equals 2, what if this plus 2 was a -4, for example? Then we would get -4 equals -4, which is a true statement. So if that was the case, then we would have infinitely many solutions, and the solutions would be the equation of the line. So there is a difference between -4 equals -4, which is a true statement, or -4 equals 2, which means there is no solution. Question 90. Determine which of the following pairs of triangles are similar and explain your work. So on part A, we have 60 degrees and 60, so those are congruent. We also have 40 in right here, so that means we can figure out the third by using the triangle angle sum theorem. So if that adds up to 100, this has to be 80. Same thing over here, 60 and 85. So that would be 145, which means we need 35 more degrees here. And since those angles are not congruent, because for triangles to be similar, we need all the corresponding angles to be congruent. So therefore, these two triangles are not similar. All right, on part B, we have 50 degrees, and we can see that matches up here at 50 degrees. We're once again missing a side here, or an angle I should say. And so 50 and 45 is 95. And so if you take 180 minus 95, you will get 85 degrees, which now you can see this angle is congruent to this angle, and then therefore this angle right here would be 45 as well. So you can see all three angles, not that we need all three of them, but we know two of them are congruent, so therefore these triangles are similar by the angle-angle similarity. On C, we have three sides, no angles, so we won't use that idea. We're just going to use the sides and see if they are all proportional. So we'll go from this triangle to this one when we write our ratios. We'll start with the smallest side of 12 and match that up with the 6. So 12 over 6 is equal to, then we'll go with the middle number, 14 and 7. And then the larger number, 16 over 8. And if you reduce all of these, we get 2, 2, and 2. And since they all have the same ratio, they are similar by side, side. And let's go back just a second here. We see that the, haven't quite got to that yet. So we see that all of the zoom factors are 2. So you can take 2 times 6 and get 12, 7 times 2 to get 14, 8 times 2 to get 16. If you're going that way, that would actually be a half in terms of your zoom factor. So we do know they are similar because all side lengths have the same ratio. So once again, make sure you are explaining your work as you answer all these questions. Question 91. The dashed line below represents the line of symmetry of the shaded figure. Find the area and perimeter of the shaded region. So we can just kind of start marking around in terms of the shaded region that we know based on the other side. So that would be 10. This side would be 4. And that length is 4. But that would break these up into 2 and 2 if necessary. And then that side would be 3. So we can find the perimeter based on those things. We'll just kind of work around starting with this 10 and then going around the figure clockwise. So 10 plus 4 plus 3 plus 4, I'm going to use that whole length right there, plus 3 plus 4 plus 10. So if we add that up, that'd be 17, 34, looks like 38 units for the perimeter. Now to find the area, we're going to have to split this up a little bit here into figures that we know. So we can do this shape right here, which would be a rectangle, and that's a 3 by 4. So we know this will be 12. Alright, and then we have the triangle. This would be a length, so we do need to know this is 2, so that this length right here represents 6. So once again, this whole thing is 6 units. So we can use Pythagorean theorem to say that 6 squared plus, we'll call this the height of the triangle, squared is equal to 10 squared. So that's 36 plus h squared is 100. Subtract 36 from 100 and get 64. Take the square root and get h is equal to 8. And so now that we know this is 8, alright, and really those two triangles, technically you can kind of match them up because they're symmetric and create a rectangle there. Or if you want, you can find the area of each individual one. The area of each individual one would be 1/2 base, which would be 6 times the height, 48. So each of these would be 24, but the whole thing then you can see is 48. So you can do that a couple different ways, but we'll add up what we know. We have 12 for the little rectangle on the bottom, plus 24, plus 24, or 48, however you want to do that. And it looks like we should get an area of 60 square units. So area and perimeter. Question 92. Determine whether or not the reasoning in the flowchart below is correct. If it is wrong, redo the flowchart to make it correct. So 2 facts. All dogs love water. Max is a dog. So is it true that if all dogs love water, and Max, who is a dog, then that means Max loves water? And the answer to that is the reasoning is correct because Max is a dog, and if these are true statements and all dogs love water, then Max must love water. Question 93. Examine the diagrams below. For each one, write and solve an equation to find x. So on part A, we see that this is an equilateral triangle, which means the angles are also all congruent. So therefore, 4x minus 12 times 3, because they're all the same, or you can add them all up either way, is equal to 180. You could do it that way, or if you understand that these all must be 60 degrees, because they're equilateral, you could have just said 4x minus 12 is equal to 60, which is the same thing. So go ahead and add 12 to the other side, which is, 72, and then 72 divided by 4 gives us 18. So x is equal to 18 degrees. Part B, we have a right triangle, so we can use Pythagorean theorem. 3.1 squared plus the other leg, x squared, is equal to the hypotenuse, 4.9 squared. So this gives us 9.61 plus x squared is equal to 4.9 squared, and that's 24.01. Now we can subtract 9.61 from 24.01, and that's 14 and 4/10, and then we can take the square root of both of those, and we get x is approximately 3.79. And we'll put some units on there as well. Alright, on to part C. We have 2 parallel lines, and you can see that by the arrows indicated. We also have a triangle right here, so we can figure out this angle by using the triangle angle sum theorem. So we've got a couple different options in terms of what we want to look at. Let's go ahead and find that angle first. So we'll take 180 degrees, subtract 103 degrees, and then subtract 51 degrees. And I'm not sure that necessarily this is going to be helpful, but it's something that we definitely can find out, so let's go ahead and do it. So that'll give us 26 degrees. And then now, if we look at the parallel line, so this parallel line, here's the transversal. What do we notice? Well, we have that 26 degrees is going to come into play because we know alternate interior angles are congruent. So that's 26 degrees, which now we can do 180 minus 26 degrees minus the 82 degrees is going to give us the x value. And therefore, x is equal to 72 degrees. And then on part D, we have a square, and we know that based on the 4 equal sides. And I guess we don't have the right angles, so we don't necessarily know it's a square, but we do know that the side lengths are all the same, so we should be able to say that 2x plus 9 is equal to 3x minus 2. So it could be a square or a rhombus, but either way, we know those side lengths are equal. I'm going to subtract the x to this side, add 2 to this side, and it looks like we get x equals 11.